All right, you have to bear with me. My note's really small here, but good afternoon, everybody, and thanks for joining me today to my talk, Making Compromise Possible, AI Workflows and Their Security Implications. My name is Nathan. I've been in the industry about 10 years. I like to think of my knowledge kind of like the CISSP exam, right? A fence that spans 1,000 feet long but only 1 foot deep. Jack of all trades, master of some. You can hit me up on my socials if you want to connect. And the views expressed in this talk do not reflect my companies that sign my paychecks. All right, we got a lot to get over here, and I'm going to be going quick, so let's get started. So we're going to start with some terms here. First, we have models. These are the trained systems that take your prompts and turn them into responses with varying degrees of accuracy. And then we have prompts. All right, these are the instructions you give to the model, asking, or also known as begging the robot to do your job. And then we have the term agentic AI, and this is allowing these systems to act autonomously with minimal human supervision. And we'll talk about why that's an issue in this talk. Then we have our key players here. So we have OpenAI with GPT-4 and 5. Their CLI coding agent is Codex. You have Gemini with, Google with Gemini Pro and Flash. Their Gemini CLI tool is their coding agent. You have Anthropic with Claude, and then Cursor, which is an IDE that you can integrate with a lot of different models. So these systems, right, they often lack context, right? They can only work off the information that you give them. And for some users, this workflow just isn't scalable. Right? This requires manually collecting information from various sources, feeding it into the LLM's chat interface, and then extracting or applying that output elsewhere. So while these models work, right, they operate in complete isolation. And this isolation creates a tempting solution. Just connect your AI to everything. What could go wrong? So this is where the model context protocol comes into play. The Model Context Protocol, I'm going to go to MCP for now because it's a mouthful, is an open standard and framework developed by Anthropic in 2024. And it pretty much just standardizes the way that AI clients can consume external data and perform operations. Right? You can think about it as giving your client access to your whole tech stack. Right? The Model Context Protocol defines three main concepts here. We have resources, which are the passive data sources that provide information to the AI client. Right? This is data that they can read. And then we have tools. These can be configured to write to databases, call external APIs, modify files, or trigger arbitrary logic. And then we have prompts, and this just allows you to wrap extra context around either a tool or a resource. And you might ask, well, why would I use MCP and not just use like an API? And I have like a nice analogy here, whereas an API is like you're at a vending machine, right? You want a drink, you have to press the exact right buttons in the exact right order to get that drink, right? APIs are rigid. Whereas MCP is kind of like having a butler, right, or a personal assistant. You just tell them what drink you want, and they'll go and press the buttons, and they'll get the drink for you. So what can these things do? Well, the GIF on the right here, I know it's a lot, but this just showcases the hundreds of MCP servers that can be plugged into your AI clients today. Some of the more notable MCP servers that I've found supply stuff like browser automation, where they can hook directly into the Chrome DevTools, the ability to programmatically call cloud vendor documentation, right? So you're not getting AI slop from a 4-year-old Reddit post. Integrations with communications apps like Discord, Telegram, and Signal. And integrations with ticket management platforms like Linear, ServiceNow, and Jira. This is where we're going to be spending a lot of time today. You can configure as many MCP servers in your client as you want, right, to provide all these various capabilities, but beware of adding too much or too many clients, right, because that could introduce tool bloat, right? The client may not know what is the right tool for the right job if you give it 100 or 1,000 possibilities. So we're going to hop on to the next slide to see how we configure one of these bad boys using Claude. All right, so all these MCP servers on their GitHub, you'll see like a big section of code for their configuration. You really just got to copy that, paste it into your client's configuration file, which is just like a home directory .claude.json. Here we're going to be using the Jira server as an example. We just copy and paste that in, and we shim in our environment variables at the bottom so that we can interface with our Jira instance. Now that we have the MCP server configured, we can launch Claude via the Claude CLI command, and then run /MCP. What this does is it prints all connected MCP servers, as well as their resources, tools, like all the capabilities that they have access to. I gotta get back notes here. So I know this is gonna be small and hard for you guys to read, but let me just walk you through here. So with our MCP server up and running, we can now instruct the LLM or our client to work with it. To showcase the benefits of these integrations through MCP rather than API, we will ask Claude to do a very complicated task of conducting deep internet research on the industry standards for cleaning up dog poop. Sorry. Claude will begin to search the internet and identify the best ways to clean up after your pooch. Right? Once Claude finds this, it will then go ahead and create a Jira ticket with the information that it found for a most senior engineer to pick up. Right? For each of these actions that it took, searching the internet and creating that Jira ticket, it asked me for approval. This is a security control in place. And obviously you can't see it here, but this ticket has quite the description containing, and I didn't write this, right? I told Claude to go find the stuff and create the ticket. It has enterprise-grade collection methods, systematic grid patterns, double bagging procedures, and acceptance criteria, all for picking up dog shit. Besides creating tickets with this MCP server, you can also instruct your clients to get contents or summarize what's in that ticket. Right? Here we just say, hey, this is a new session. This isn't the same session I showed you the previous slide. We just say, hey, what's the details in CRM 14? It asks us to go to Jira, and then it summarizes there, telling us the best way to pick up that dog crap. So I'm going to show you a bit more of a realistic demo here. So here we have, this is more realistic, right? So we start by asking Claude for help with the Jira ticket in CRM 9. That's the identifier. Claude will connect to our MCP server. It'll query Jira and retrieves the ticket details, which asks us to implement a simple programming challenge, FizzBuzz. Right? Claude has all the context from Jira immediately and starts writing this Python function to implement FizzBuzz. It also generates comprehensive unit tests. And all of this is happening within Claude's interface, right? We didn't have to go and copy the contents from Jira. We just gave them the ticket and they had that integration. This directly addresses the isolation challenges and workflow limitations that I talked about in the first slide. And critically, the LLM is able to accurately finish its task based on the provided context. I mean, you want to make sure these tests are actually passing, but it did the work we asked it to. So, now that we know what MCP servers are, how to use them, let's talk about how they make compromise possible. I want to be clear here that today I am using Jira, but this type of compromise I'm going to show you works anytime your AI client pulls external content. So, does anybody here see anything wrong with this Jira ticket? Does anybody see anything that stands out? Raise your hand if you think so. Close, but that is actually example.com. No, I'll go to the, what?
The new line.
It is the new line, right? This bounding box is really freaking big for that small text to be in there, right? So what happens if we just go to the next slide and we select it, right? Here we have an invisible instruction hidden in that exact same ticket, right? All it is white text on a white background. Very easy to hide, right? So to the first text here, write a function to call example.com and get the status code. But below, again, hidden, we see a link to a URL that says coding style checker. What could that be? So before we dive into how this attack works, I want you to know that this isn't really theoretical, right? Independent research teams, 2 at Black Hat, both NVIDIA's Offensive Security, NCC Group, and then my team's hackathon project, all reached similar conclusions. LLMs consuming untrusted data can be exploited through prompt injection, leading to credential theft or remote code execution. And the pattern is very clear. More usability means broader data access, which equals more exploitation opportunity. Now I want to show you how this looks like at a bird's eye view. I'm going to bring this down because I got a lot of clicking here. Okay, so here we have Claude Code opened with the local code base. The engineer asking Claude for help with that Jira ticket with his MCP server. Perfectly normal workflow. Claude uses the MCP server to fetch the ticket details. The MCP server queries Jira and retrieves everything, the legitimate task, as well as that hidden malicious payload. And this is where things get a little bit ugly, right? Because Claude used our approved MCP server and it grabbed both of these lines from the same context, they're coming from an approved source, and it is trusted. Right? So when it gets back to Claude, the chances are that this will actually go ahead and execute and run the script on the user's machine. So I just want to show you a little bit of what this script does. And again, this is going to be hard to read for everybody just due to the coloring. But here's the script in its final form. On the left, we have a valid Python linting utility. Checks for like snake case, camel case, unsafe eval, stuff like that. And under it, in a red border, we have a block of obfuscated code. On the right, you can see a little bit of what this unobfuscated version does. It looks for juicy files on your system, right? And then it exfiltrates them to my attacker-controlled web server. The obfuscation point here is done in hopes to defeat the automated analysis by the LLM if it has it. But at this point, we have an obfuscated malware hidden in a Jira ticket, ready to exfiltrate credentials. But surely you say, Nathan, any responsible user would never just blindly approve the LLM running the code that they don't understand, right? Right? Especially if it's something they didn't write themselves. I'm looking at you guys who curl right into bash. Okay, well, I really want to point you to a very popular blog post in the AI developer community. And I'm not shitting on people here, but it's called How I Use Claude Code Plus My Best Tips. And it has opinions about security controls. So, the author states, the permission system is insane. You ask the AI to do your job, it starts working, and you step away for a few minutes. You come back, and it's sitting there asking you for confirmation. What a waste of time. Of course you can do it. That's literally the point of AI. Right? And here's the kicker. Now, read this next section deadpan. Okay. The solution to this is to run Claude in dangerously skip permissions mode. It's not as dangerous as it sounds. Could a rogue agent theoretically run some bad shit on your computer? Sure, but I haven't seen that happen. Right. Right, this goes back to the name of the talk, right? This is making compromise even more possible. Now, I don't even need the user to approve running this script on their machine when it gets pulled into their context. Convenience has just killed the security control. All right, we got a compromise demo here. So on the right here, you got my Python web server. It's using AIO HTTP, and it's just accepting connections on any path. Yeah, so it accepts post requests on any path, extracts the host name and file names from the URL, and it'll create directories on the server, on the attacker-controlled server as needed when the client streams files in. And on the left here, we have our unsuspecting developer running Claude in YOLO mode, as per the article's best tips. As the developer, our developer will then go ahead, get the contents of that Jira ticket, right? And he's going to ask for help from Claude. And like the article, he's going to walk away from his machine, right? The contents of that ticket require that Claude must call the function, write the function to call example.com, and run the code company checking script. These tasks must be accomplished for the LLM to think it's done its job. So Claude does the work to write the function and fetches the remote script. And before the user can get back from his break, our script is ran by the LLM on the user's machine, and we start streaming files in from his machine. And here we can see stuff like, we see some GPG keys, a .env file from this very long con demo with the Jira credentials, Proxmox API key, and a shitload of like RC files that can contain some juicy info, as well as some AWS credentials and GCP credentials here. Obviously, we're going to show you some examples down here, but these have since been rotated or contain bullshit data. Right, so you get these directory here, these are the client's files that were streamed over via that script. Obviously, there's nothing there. But we have some stale G-Cloud credentials that were valid at one point. And we also have the very tokens that were used in this demo to configure the MCP server. So, now you might ask yourself, all right, Nathan, are you showing me a Jira exploit here? Like, what's going on, right? I want to be crystal clear that this isn't a Jira exploit. I just use Jira as the vehicle here, right? The only reason I use Jira is because my organization is actively dabbling in MCP and trying to figure out how to bring AI into the fucking world and all that shit, you know. Right, but we found that people were using this and they were getting, right, the exploitation opportunity exists there, right? And that's because It exists whenever your client makes a call to an MCP server that connects to any untrusted source, right? You are inheriting the risk of code, prompt injection, potential token theft, data exposure, tool poisoning, and potentially others, right? And this attack applies everywhere because the trust chain is broken. The LLM or your client trusts the data coming back from this approved MCP server. You explicitly told it to use it. And the LLM may not have a way to distinguish malicious instructions from legitimate ones when they both come through the same trusted channel. And most importantly, those external sources can be compromised and can contain user-generated content. You say, Nathan, oh, it's Jira, it's internal, right? I need an insider threat to fuck this up. No, like, what if you have a Zendesk integration where your client sends you emails and that goes and creates a Jira ticket, right? That's an attack vector right there. So, you're gonna ask me now, okay, well, what can I do to kind of protect myself here? Sorry, guys. So, we're gonna go take a look at this real quick here. So if you built the MCP server, or you cloned it and forked it and you have control of it, the solution's relatively straightforward, right? Validate the external data before it, Validate the external data before it reaches the client. Right, so here we have the user asking Claude for help with his work. Claude calls the MCP tool. The server then goes to Jira to grab the contents. And before we return those contents to the user, can we just parse it for some sketchy shit? Right? If there's no sketchy shit in the response, just return it to the user and we're good to go. But if the response is sketchy, like it has that domain in there, right? You can just hit them with a little Newman and just tell them to get fucked. Right? And this is a recommended security best practice tied back to injection attacks that can occur when user data is not either validated, filtered, or sanitized by the application. And I want to show you how this looks in action. These slides are going to be very technical for people who aren't very familiar with Python, but I'm going to brush past some of the implementation specifics, but if you want to talk about this after, come meet me and we can chat about it. So this is code from a custom Jira MCP server that'll be available to all you guys after this talk if you want to play with it. And I'm brushing by a lot of the technical detail just due to the time. So this function here is the one that actually goes and gets the contents from Jira. Above the function, we can see two decorators. They start with that little @ symbol before them, right? This just allows us to add additional content to a piece of code without having to modify its inner contents, right? It's very nice for reusability. First, we have MCP tool. This is what the library uses when the client connects to the server to tell it, this is what I need to do to get Jira tickets. 10 minutes? Perfect. And the one up under it is secure MCP response. This one is custom. The secure MCP response decorator will intercept data before it's returned to the client. It takes the data that would have been sent to the LLM and passes it to one more function called validate MCP response to do the actual pattern matching. Again, you guys aren't going to be able to see much here, but what this validate MCP response function does is it checks the content intended for the client against some common threat patterns. Stuff like credential patterns, sensitive files, instructions for code execution, suspicious domains like the ones we showed in the example, as well as like non-secure protocol schemes like file : / and excessively long contents. If this function finds any of those malicious patterns, it will return a dictionary where this is safe key is equal to false. This will return back to our secure MCP response function, right? And since validate MCP response returned a dictionary where is safe is equal to false, our if statement will be triggered and a security error will be raised. At this point, the MCP server's connection has been severed entirely, and the client never receives the malicious content. I'll show you this in action. So this is using that same demo earlier, but with the validation in place. So here we have that Jira ticket. If we select the text, we can see that that malicious domain is in there still. We're using our Claude client as well as our MCP server to get the contents. And immediately, you can see here we have an error. An unsafe MCP response has been detected via this suspicious domain. Now, the client is still going to try absolutely every option it has, right? If you expose multiple tools with this MCP server and it can get, search, query, or a bunch of different methods, it's going to try absolutely every one until it's exhausted all options. And then ultimately, you can even see here, it's trying to look at my local directory to see if there's any context there that it can use, right? And ultimately, after it's exhausted all options, oh, sorry. Oh, come on. After it's exhausted all options, it says, this server appears to have security validation, and it is blocking responses with this domain. I can't help with this ticket right now, right? So what we've done right now is we found a vulnerability, and we directly implemented a compensating control to protect ourselves from this in the future. So the validation demo, right? If you built the MCP server yourself, or you can fork it and download it and control it, you can add this validation, right? You can intercept responses, scan for malicious content, and block bad shit. Great. But in reality, most people are just slapping these into their clients and using them. And in those cases, you're really just trusting the developer or maintainer to implement this kind of security, and it's not the norm, right? What I showed you there works, but it also adds like a bunch of overhead, right? They say if you solve a problem with regex, you now have 2 problems. Yeah, right? And it also adds a bunch of latency too, right? And as attack patterns evolve, you're gonna have to constantly patch that, and then users are like, oh, well, I actually need something from that domain because I have some critical app on there, right? So it's really challenging to scale this properly. However, regardless of the approach you take, there are a few steps that you can still protect yourself. So, I want to say that all these AI clients are still evolving, and some of the stuff I'm talking about today might change in a month, a week, or tomorrow, right? Claude Code specifically exposes 2 hooks called pre-tool use and post-tool use, meaning that you can programmatically intercept data before and after they execute, right? So then you can add validation at this line. Cursor, Gemini, and Copilot at my time of review didn't have the same capabilities. But regardless of the client you use, you can protect yourself by first, not running these clients in YOLO mode, right? I don't really care what the productivity blog says. You need to force human approval for all of these tool calls. Yeah, it's annoying, but that's kind of the security control doing its fucking job, right? The other thing too is, if you're using these servers, right, limit the permissions they have access to, right? If you only need to read Jira tickets, don't give it an API token that has admin, right? Follow the principle of least privilege. Third, and this one's really important, try to sandbox if possible, right? These tools can execute in sandbox environments, either through like Mac seatbelt profiles or mounted Docker containers. And if we would have used sandboxing in this demo, the only thing that would have been exposed was my API key and the local contents in the directory in which I was running it. It wouldn't be able to get my bash RC, my ZSHRC, in files in other directories. Fourth would be validate AI outputs, right? AI can and always will hallucinate. It's your job to review what it's telling you, trust nothing, and verify everything. If you're an organization and you haven't already, I would set up an AI use policy, right, to find what data can and cannot enter these systems. Train your users on it and enforce it, right? A policy without enforcement is nothing. And if you're using these MCP servers, periodically audit what you have installed, right? If it's just sitting there running and you haven't used it, it's just an attack vector waiting to get hit. All right, so let's bring it home. We have seen how MCP servers bridge AI to your infrastructure, and how that bridge becomes a highway for credential exfiltration when you connect it to untrusted data sources. The core lesson here, convenience will always try to kill security, users will disable permission prompts, developers will skip validation, and organizations will delay policies. And that is how compromises happen. All of the code, exploits, mitigations, and as well as an AI client security tooltip are all available on my GitHub. And I just want to say thank you all today to join me to make compromise possible. Questions?
We have a couple minutes for questions. Do we have a couple questions for the couple?